Welcome to EDU World Space.
All right, so we want to express this integral in 6 different ways. Yes, we want to do this in 6 different ways. So first thing that we're going to do is we're going to say, what if we just look at this, our solid in the xy plane? So that means z is equal to 0. So we get this here, and we've graphed this here. So we can see the bounds on x, -2 to 2, bounds on y, 0 to 4, minus x squared, and then the bounds are of z. Well, it's just what happens, right? Bounds on z here. It just happens when we solve for z here, okay? We can see that we can put this into this integral, right? Integrating the z, then y, then x. But what if we switch these two? What if we do x, then dx, then dy? Well, we're going to have to switch these two integrals, and we're going to look at this region not as region 1, but as region 2. Okay, so that's what's going on there. And then this guy here is still the same. Okay, so there's the first two. What if we look at it in the xz plane? So y is equal to 0. So this guy is really just an ellipse, as I've drawn here. So if we look at it as region 1, x is going from -2 to 2. Y is going from, z is going from negative square root of this thing to positive square root of this thing. And our y, well, our y is just as it was given here, okay? So let's write this as an integral, right? So since y is 0, so we go -2 to 2. Then we're going to do our z bounds from negative square root of 1 minus x squared over 4, square root 1 minus x squared over 4, 0 to, it's going to be 4 minus x squared minus 4z squared of f, x, y, z. So we do dy. And then we did dx, correct? Yes, we did dx. Dz, and then dx. Okay. So if we switch these two integrations, well, we're just switching our region 1, which went like this, to region 2. Okay, in the region 2, it's from -1 to 1. Then we need our bounds on x, which are negative square root of 4 minus z squared to 4 minus z squared square root of that. These bounds are still the same. F of x, y, z. dy is still the same. Then we got dx, dz. Right? These guys switched. All right, so those are the 4 integrals. We need 2 more. All right, so now we're looking at the yz plane. So x is equal to 0. So that means y is equal to 0, and y is equal to 4 minus z squared. Okay, this is our y, and this is our z. Our graph looks like this. So here is 4. That's this guy. Okay. So let's do, it really doesn't matter what region we do first. Let's do it as a region 1. So 0 to 4. And how are my z's going to be ranging? Well, we need to solve for z here. So let's see. Once we solve for z, get 4, not that. We get 4 minus y over 4 square root, and minus 4 minus y over 4. And then our x bounds, well, it's when we solve for x in this formula here. Okay, so solving for x there, we get 4 minus 4z squared minus y. Yes, and 4 minus 4z squared minus y. Okay, So now we need to put this into an integral. -1 to 1 for the z bounds. Our y bounds, like so, and then our x bounds. Of x, y, z, we do dx, then we do dy, and then we do dz. So switching these two, we just have to switch from region 1 to region 2. So doing that, we're going from 0 to 4, from square root of, I'm sorry, I think I made a mistake here. Yes, so this should be, give me 1 second here. So 0 to 4, z bounds are changing like this. Okay, that's right. And our x bounds are changing like this. So we do dx, then we do dy. Yes, this is correct. Yes, this is correct. So then we want to change our bounds. Yes, we want to change our bounds to reflect the other one. 4 minus y over 4, 4 minus y over 4, negative square root of 4 minus 4z squared minus y, square root of 4 minus 4z squared minus y, f of x, y, z, dx, dz, dy. Yes, so this here is correct. Yes, this is totally fine. Yes. All right, we're done.